Hello. Today I want to take a couple of minutes and talk to you about matter some more and specifically properties that matter has. We're going to try this a little bit of a different format. So remember the last set of notes we did, I hand wrote out the notes as we kind of went and I discussed them. But that made the video really long because I was writing at the same time. So now I'm going to try this with a PowerPoint. You are going to take notes and write them out and make or you're going to eventually, when you're done, take a picture and submit it, just like we did last time. But while we're going through this, besides concentrating on the information that I am sharing with you, I also want you to think about which kind of a format you like better, because I will be asking you next week, like if you prefer when I write it out or this PowerPoint. So anyway, just kind of so you know where I'm thinking, I want to know from you guys what works best for you. So anyway, back to matter. So first thing, remember that matter can be described, which is what we were doing last week. We were describing the qualitative properties of matter, and it can also be identified by its properties. So we can describe and identify matter by its properties, and there's basically two types of properties. So the first type of property that I want you to be aware of is something called an extensive property. And extensive properties change based on the amount of matter present. So like if you start with one scoop of something and then you add 3 more scoops, the property, whatever it is that you're looking at, would be different because you added more, right? We added more matter. Because they change based on the amount of matter that's present, you cannot use them to identify a substance. For example, if I was to walk into class and give you 100 grams of a white powder and say, can you identify what this is because you know there's 100 grams, you wouldn't be able to, right? Like it could be 100 grams of absolutely anything. I could get 100 grams of 10 different chemicals and you wouldn't be able to identify what they are from that amount, okay? So extensive properties are those things that cannot be used to identify a substance because they change. So again, examples of this would be things like mass and volume. As you add more matter, you're going to get more mass. The grams is going to go up on the balance. The volume that it occupies, so the space in the graduated cylinder, would go up. So we can't use them to identify. So the other type of property that I want you to know about then are intensive properties. And these properties we can use to identify substances. Maybe not necessarily all alone by themselves, but you can have a handful of intensive properties and be able to identify what something is, okay? So intensive properties do not change based on the amount of matter present. And because of that, we can use them to identify a substance. Some examples of this would be things like color, right? So I know color, like for example, if we're looking at like a blue solid, and maybe if you have 1,000 grams of that blue solid, it looks a little bit different than if we just had 10 grams because of the amount. But at the end of the day, it's the same blue, right? Or the hardness, for example, like if you had, 2 pieces of marble, even though one was tiny and one was large, they would still have the same hardness. Okay, same thing with melting point. The melting point of a substance does not change. So it might take longer to reach that melting point if you have a larger sample, but it's still going to melt at that same temperature. And then finally, density, which is kind of the focus of our lab that we were doing in class this week and of our practice problems. Okay, so we're going to talk a little bit more about density now. So I have here a picture of gold versus a picture of copper. And based on just this question, what do you think is heavier, gold or copper? Well, the answer to that question really depends on how much you have, right? You can't answer that question unless you knew exactly, like you had the exact samples right in front of you. So copper could be heavier if you had way more copper, if you had way more matter than you did of the gold. It totally depends on the amount you have. Now, what if I gave you the exact same volume? So I gave you a chunk of gold and I gave you a chunk of copper that you dropped into a graduated cylinder full of water, and they changed the volume the exact same amount. So they have the exact same volume. Then could we say which one is heavier? Right? In that case, we would discover that gold is denser than copper. Okay? So gold is denser than copper because we would say that it's heavier. In other words, it has more matter. So what exactly is density then? Density is the amount of matter per unit of volume. That volume is usually a milliliter, so it's the grams per milliliter. The way we calculate density is we take the mass and we divide it by the volume. So the mass in grams divided by the volume in milliliters, and that gives us a working density that we can use in our lab. And here's a little picture to kind of help us understand this idea. These two boxes have the same volume, and this box, the box on the right, is more dense than the box on the left because there are more atoms present. There's more matter present. So this would feel heavier when you tried to go pick it up, right? Because it would have more atoms in it in the same space, okay? So this is the equation for density. You guys maybe saw this in middle school. I feel this is a real common thing. They use the heart, right? Where the top of the heart is the mass, which we, of course, are going to measure in grams. Sorry, I got to get myself out of the way there. And then you have on the bottom the volume, which we're going to measure in milliliters. Now, does it always have to be grams over milliliters? No. You just have to be careful that you're always taking mass and dividing it by volume, but you can do different units. For example, you could use kilograms. For volume, you could use cubic centimeters, which I'll talk to you more a little bit about here in a couple of seconds. Okay? So, real basic, you just need to know that density is equal to the mass divided by the volume. What we're going to do next is go over a couple of example problems, okay? So let's try this out. Again, I'm going to just, hold on, I got to switch over here to my document camera. I'm going to write the equation out one more time, that density is equal to mass over volume. Now, I'm betting that most of you probably already know that without even having to write it down, but just in case you don't know it for sure, make sure you get it written down. And of course, mass is going to be grams and volume is going to be milliliters in the case of this problem. So to solve this problem, we have to look out for the mass and we have to look out for the volume. So a gold ring weighs 7.5 grams. I'm a big fan of underlining information as we're given it in a question just to kind of help keep track of everything. And it has a volume of 0.388 milliliters. So what will the density be? So this will be really easy. We're going to plug in the mass to our equation. Then we'll plug in the volume, which is 0.388 milliliters. Okay. And then all we have to do, we know that when we have something written like a fraction like this, that line means divide. So we're going to take 7.5 and we're going to divide by 0.388. And let me get here a calculator. Okay, so I'll do 7.5 divided by 3.88. Oh, excuse me. It's supposed to be 0.388. And we get 19.3, and we're going to round to 2 decimals. So we're going to look at that second decimal place. We see that the next number is bigger than 5. So we'll do 0.33. And then what's the unit for density? Well, the unit is exactly what we did. It's grams divided by milliliters. So when you go to solve these practice problems on your own, you're going to need to make sure that you put that unit G over ml, grams over milliliters. Okay? Super easy. We're really easing into chemistry right now. This stuff is so easy. Let's look at another example. Okay? In this question, we want to know the density of a piece of wood that has a mass of 25 grams and it measures 2 centimeters by 3 centimeters by 4 centimeters. Now, this is different. It says nothing about milliliters, right? And we're also talking about a solid piece in this case, which must be regularly shaped because we could measure it. So in order to find volume, you can take the length times the width times the height. So we're going to do 2 times 3 times 4, which will give us 24. Now, what's that going to do to the unit? Each of these numbers were centimeters. So we have centimeters times centimeters times centimeters, which means our answer will be in something called cubic centimeters. Now, you've probably heard of cubic centimeters without even knowing it. If you've ever watched any kind of like a medical show, you'll hear them say, give them 100 cc's of such and such stat, right? The cc is referring to a cubic centimeter. So a milliliter and a cubic centimeter are essentially the same thing. This idea is really super important. This conversion fact is really important for you to know. So I'm going to just kind of do this. Make sure that you for sure get that written down somewhere. And in order to convert or find the volume in milliliters, since that's the unit that we're attempting to use in this problem, we're going to take 24 centimeters and turn it into milliliters. Well, it's just a 1-to-1 ratio, right? So we're not going to show any silly math. We're just going to say that it must be 24 milliliters. So our piece of wood has a volume of 24 milliliters. So now we can go back and solve that problem. And again, density is equal to mass over volume. So the mass in the case of this problem is 25 grams. Forgot to underline that. And we just calculated the volume at 24 milliliters. So again, to get the answer to this question, we're just going to take 25 and divide by 24, and we get 1.04. Remember, we look at that third number, and it's not over 5, so we're not going to round our second number. So this is 1.04, and again, the unit for density is basically just what you did. So grams divided by milliliters. Okay, that's example number 2, right? Real basic. Okay, last example problem we're going to do is going to give you the density this time. So this is kind of different. It tells us that the density of pure iron is 7.84 grams per milliliter. Now, what does that really mean, right? 7.84 grams per milliliter. What that's saying is that 7.84 grams is equivalent to 1 milliliter. In other words, if I have 1 milliliter of pure iron, so I have that volume of iron, then I know beyond a shadow of a doubt that it's going to have a mass of 7.84. So this becomes a conversion fact for us. So you can think of density as a conversion fact. Okay, so back to reading here. If I have a sample of iron that has a mass of 35.89 grams, what is the volume? Okay, so let's think about our equation here. We know that density is equal to mass over volume. So one thing that I could do is I could plug the numbers in, right? And I could solve for the missing variable. So I have the density and I have the mass, right? So let's just write that in here. So I know that it's 7.84 grams per milliliter is equal to 35.89 grams over the volume, which we don't know. And then we just do math, algebra, basic algebra to solve for this. Okay, so that's one way that we could solve this problem. Another way goes back to what we just discussed about how this becomes a conversion fact. So if we know how many grams we have, we can use this conversion fact written as a fraction, just like we did when we did our unit conversions, and that will give us our volume as well. So if you were to do that technique to solve the problem, you would take 35.89 grams as your starting point, and you would multiply it by the conversion fact written as a fraction. And remember, what we're trying to do is get rid of grams and have milliliters. So if I have grams on top, where will I want grams in my problem? Very good, on the bottom, because we want it to go away. So we put the 7.84 grams on the bottom, and we put the 1 milliliter on the top. Remember that you can write this conversion fact as a fraction with either number on the top or the bottom. So it doesn't matter, it all still equals the same thing mathematically. So you pick the way that you want to write it in order to get rid of or change your units. So the grams are going to cancel, and I'm going to be left with milliliters, which is what I'm looking for, the volume. And then I just need to solve it. Okay, and in order to solve it, I'm going to take the given and multiply it by the top number in the fraction, which is 1 in this case, and divide it by the bottom number. So we're going to do 35.89 times 1 divided by 7.84. So 35.89 0.89 divided by, oh, I forgot the times 1 part, although that doesn't change my answer. So times 1 and then divided by 7.84. And I get 4.5, and see, I look here at my second number, right? That's 7, so I look next to it, and there's a 7 there. So since that's above a 5, we're going to round up to 4.58, okay? And we know that the unit here is milliliters. So the answer to the question is 4.58 milliliters. Regardless of whether we solve the problem this way or you use it as a conversion fact, you should get the exact same answer, 4.58. So you can do whatever makes sense to you. A lot of people struggle with an unknown variable on the bottom of an equation like this, and they get all tripped up by the math. If that is you, then I would recommend writing the density as a conversion fact like I did here and flipping the fraction around however you need it to solve, and you'll get the same answer. Okay? So that's all that I have for you in terms of notes. Again, remember, you're going to take a picture of your notes and submit them to me. Now that you have watched the notes, you're going to go on to Google Classroom and you're going to get the practice problems and get those completed. You'll notice that the top 3 problems are example problems. Those are the exact same 3 problems that we just did. You can rewrite them if you want to and then come back and watch this video, or you can just leave them. It doesn't matter to me. But you have a handful of questions that you need to complete on density so that we can make sure you are learning the topic. Okay? As always, if you have any questions, please let me know. And I will see you guys later.